Hey there, educators, and welcome back to the Make Math Happen podcast. I'm your host, Lanisha, and today we're starting season 4 with a conversation I've been wanting to have for a very long time. We're talking about geometry, not the formula heavy, memorization driven version that many of us experience. Geometry is the foundation of visual reasoning, sense making, and connected learning across the entire K 8 journey. And I mean this, geometry is the thread that quietly prepares students for ratios, proportions, equations, and even functions. It's the story we often skip over because we're uncomfortable with it, but it's also the story that can transform middle school math when we tell it well. So let's jump in. Did you know that geometry starts in kindergarten and not middle school? I want to start with something obvious, okay? But it's often overlooked. The geometry work that we're doing in middle school isn't the beginning, it's the continuation. If we go back to kindergarten, students are already identifying and describing shapes. They're talking about their positions and building figures with blocks. Those experiences aren't just cute kindergarten math. They're the first steps in developing spatial reasoning, which students will rely on for the next 9 years. As students move through first, second, and third grade, they start comparing attributes, partitioning shapes, creating equal parts, and decomposing figures. All of this early work becomes the groundwork for what happens in sixth grade and beyond. And yes, on one hand, this is information that you knew, maybe. Of course, the early grades build the foundation, right? But too often, when students reach middle school and start struggling with area, volume, surface area, we jump straight to remediation through formulas instead of diagnosing the missing spatial reasoning underneath. I see it every year in my district. Students struggle with area, students struggle with surface area, and students struggle with volume. But the struggle isn't about the formulas. Sure, they don't remember the formulas and how to apply the formulas, but it's something deeper. It's about the lack of meaning behind the formula. The other day, I had a conversation with a seventh grade teacher about area and circumference of circles. She was talking to me about some notes that she had created for students, and I was really pushing her to think about how can students use the visual image that she had given them to really make sense of those two terms, area and circumference. We went to the whiteboard. I drew a circle on the board. We labeled the parts of the circle that we want students to understand, the center, the radius, the diameter, the circumference, obviously. And then we talked about the relationship between those pieces. We talked about color coding so that students can relate one thing to the other, right? So that it's not me memorizing this exactly as you've given it to me. Even in me creating the notes, in me writing the notes, I'm thinking about the connections between the pieces that are here. We talked about why it makes sense that we're using radius to find the area versus the diameter. And the whole reason why this conversation came up is because she was on the lesson where students were deriving the area formula. And I think sometimes it can be really challenging when we're moving from one concept to the other and we're doing it visually, especially when that's not the way that we've learned. But through us going through that together on the whiteboard, drawing pictures, using purposeful coloring, she was able to walk away with an aha. Okay. We were talking about what happens when we define the concepts only by their algorithms, when we're wanting students to just remember that radius is half of the diameter without giving them that visual, without allowing them to see that relationship. When we tell students that area is pi r squared and circumference is 2 pi r without grounding them in what those ideas actually measure. We need to see it. So I said to her, we give the students the algorithm before they have the images. And in her case, she was giving them the image, but the focus was on the algorithm. The focus was on the formula. But the small shift in how we define the terms, so instead of saying, what's area? And students saying pi r squared, them saying that it is the amount of space that that shape covers. And instead of them saying circumference is 2 pi r or pi d, they're saying circumference is the distance around that circular object. We are shifting that. That's a small shift from defining by formula to defining by what it actually measures. When students can visualize what that term is measuring, the algorithm becomes easier to understand, not harder. So now we're not using all of this mental energy to memorize the formula. We're just applying what we understand from the visual that we've had numerous experiences with to make sense of what we need to do, to make sense of the algorithm. In my graduate class, we've spent weeks talking about how students learn numbers and operations. And when we're talking about learning multiplication facts, which we know is a heavy topic, right? Students move through three phases: counting, reasoning, and then mastery. Notice how mastery doesn't come first. So it isn't just you need to sit down and you need to memorize these. Reasoning comes before the remembering. Okay. And if we apply that same progression to geometry, especially to area in sixth grade, we start to understand what's missing. The students need the gridded space so they can make sense of what area means. And sixth grade isn't the first time that they experience area, but we're reinforcing those previous experiences. So they need the space before they need the formula. They need tiles. They need that gridded paper. They need to build it. They need to see it. You can even try something like having students create a parallelogram with string. They can create it on the desk. They can create it on a sheet of paper. And then we can fill it with equal size squares with no gaps and no overlaps. That's important. And let them determine the amount of space measured by those squares, the amount of space that their figure actually covers. That experience could lead to students comparing the area of their figures to the area of their classmates' figures. You could start to have some really good conversation about the relationship of the figures that they've created, about the side lengths, about the space that's taken it up, about the number of squares that are inside and how all of those things connect to one another. Experiences like that help students attach meaning to the measure before the formula ever shows up. And then in a lot of cases with meaningful experiences, the students are going to start to generalize. They're going to say, oh, well, if this is always happening, that means I can find the area of a figure like this way. So it'll go from counting one by one to now us reasoning about the number of rows and the number of columns, and then concluding that I can just multiply those things. Okay. So here's the thing: sixth grade is not the first time students explore area, right? Yet they continue to struggle. Much of it comes back to our over reliance on formulas. We've turned geometry into memorization instead of understanding. So take triangles. Teachers often say students can't remember the formula for area of a triangle. I've done this so many times. Like I've told them that it is 1/2 base times height or base times height divided by 2. I've said it so many times. There's an anchor chart on the wall. The formula is right there. But the real question is, did students have enough experience seeing the relationship between rectangles and triangles? Are we again trying to force students to memorize a formula? We're trying to force them to mastery before they've had an opportunity to reason. That's the question that I want you to ask yourself when you're reflecting on the performance that students are showing you or demonstrating when it comes to area of triangles. Did they have enough experience seeing the relationship? Because if they did, the formula becomes obvious. Half of the rectangle, half of the space, same base, same height, it's half, right? That's reasoning. That's that logic. And reasoning builds mastery, not the other way around. We can't rush geometry or treat it as some isolated unit because geometry opens the door to understanding in every other domain. And so far, we've only talked about sixth grade. So let me let seventh grade enter the chat. When seventh grade opens with concepts like scale drawings, it creates a beautiful thread that leads straight into proportional reasoning. It builds intuition for increase and decrease situations, which sets students up for percentages later in the year. Scale isn't just geometry, it's ratios, it's algebraic thinking, it's multiplicative reasoning, it's proportionality. Geometry is the on ramp. We're getting ready, we're getting charged up. In eighth grade, the story continues. Transformations help students understand those eighth grade standards. Dilation creates the perfect opportunity to talk about rate of change. Translation naturally connects to us comparing proportional relationships and non proportional relationships. Reflections and rotations help students reason about symmetry and structure. It's all connected. Geometry is simply the first language that students use to describe those relationships. And the more opportunity that we give students to make sense of those relationships, to look at those visuals, to create those visuals, to derive and generalize based off those visuals, the better prepared they're going to be. I get it though. Everything feels like a rush. Everything feels like we just don't have enough time. Well, sometimes you have to be the expert in the room and you have to take the time, but you have to be intentional with it. I want to really be clear. Because sometimes we hear things and we only listen to the things that are triggering for us. So you may have heard you're the expert in that classroom, and you are, right? But you also want to be intentional about what it is that you're doing. You want to make sure that you are truly telling the story, that you are truly allowing students to see the thread. Because here's what I've noticed across classrooms. We often teach geometry like it lives on an island, ratios like they live on their own island, expressions and equations like they live on another island, and functions definitely on their own island. This fragmentation increases cognitive load. Students learn isolated topics, but they never see the storyline. They don't see the fact that this concept builds the understanding for another. And as teachers, I think we know it. Like, we know that there's a connection there, and it's in our mind, but I think we forget to say it. We forget to emphasize it. We forget to provide students with the experiences so that they can see it. And I want us to shift that, because geometry is the storyline. Geometry is the thread. Geometry is the connector. And when we start the year with geometry in middle school, we give students a powerful chance to practice visual reasoning, to build intuition, and strengthen the part of their learning that helps them make sense of every domain that follows. And you may be listening to this in December of 2025 and thinking the school year has already begun. And yes, I understand that. So I want you to take this whenever you hear it and apply it in a way that makes the most sense for you. So if students are having issues with equations, let me tell you, one of the first things that I do is I make a visual. And more often than not, students can understand the visual. They understand the visual. But there are instances where the students don't understand the visual because they haven't had enough practice with visuals. Okay? They haven't had enough practice with creating a picture to model situations. And if students aren't able to read a task and make sense of the relationship between the quantities that are involved in that task, they're going to have a really hard time answering that question. Some students may not need to draw a picture to do that, but many students do. Many students do. Okay. So one of the main things that I want you to get from today's episode is the fact that it's the connections for me. I did a professional learning session at the state math conference here in North Carolina on the connections across domains. I did that same presentation down in Florida this summer at the Hive conference, and I'm going to continue to shout it from the rooftops just how much us leveraging the connections across the various concepts that we're teaching students is really going to be the driving force in closing the gaps on these unfinished learnings that students come to us with. It's the connections for me. It's the continuity. The way one idea prepares you for the next. We have to teach math in a way that emphasizes those connections instead of reinforcing the separation that makes learning harder. So as we kick off season 4, I want you to walk away with this. Geometry isn't a unit to survive simply because it only takes up 12% of your test, right? If you're looking at those test specs, those test specs are something to give you an idea of what you could see on the test. But the reality is everything is connected. So whether you see 12% or 24%, it's relevant, it's needed, it's important. So again, geometry isn't a unit to survive. It's an opportunity to build understanding across the entire math story. Start with visuals, stay rooted in meaning, let the reasoning grow, and don't shy away from the parts that feel uncomfortable. There's going to be things that you're going to teach that make you feel uncomfortable, and that discomfort is the beginning of learning for students and for us. And as the teacher, if there is a concept that we're feeling uncomfortable about, that is a sign to lean in. That is a sign to learn some more. That is a sign to do some digging, do some researching so that you can become sharper. So that when you get up there in front of those students, they see you for the superstar that you are. Okay? Thank you so much for joining me today. Season 4 is underway and we're just getting started. Let's keep building those connections and making math happen together. I'll talk to you soon.